Now that we have introduced the notion of radian measure of angles, I wanted to go through once again and have a quick brush through a review of our reference angle families. And we'll do this in both degrees and we'll do them in radians. It's important that you know, you understand, and you have a firm grasp in your mind what the reference angle families are. So if you know the reference angle is 30 degrees and you know you're in quadrant 2, then you should be able to know what the angle is that corresponds to that reference angle in that quadrant. So any one of the basic reference angles in any one of the quadrants, you should then be able to deduce what the measure of the angle itself is being required to measure. And so we'll go through the ones with our special angles, the special reference angles of 30 degrees, 45 degrees, and 60 degrees. Now, let's recall that when we talk about radians, the key translation is that 180 degrees, this in degrees, is equal to pi radians. A straight angle can be measured as 180 degrees, or it can be measured as pi radians. If you have this relationship, then any other relationship can be found from that. So for example, suppose we wanted to have a 30 degree angle, a 30 degree angle. Well, to get from 180 to 30, you divide by 6. This is 30. If you divide this by 6, therefore you must divide this by 6. So pi over 6 is 30 degrees. An angle that measures pi over 6 radians corresponds to an angle that measures 30 degrees. And that can be done with any of the basic measure angles. So 60 degrees is 180 divided by 3. Therefore, a 60 degree angle is the same as an angle that measures pi over 3 radians. And then similarly, 45 degrees is you divide 180 degrees into 4 equal parts. If you divide this by 4, then you divide this by 4. And so pi over 4 radians corresponds to 45 degrees. And so with this understanding, knowing this relationship, then translating to any particular value is straightforward. Now, we'll also deal later on with angles that are not the special angles. What if we have a 27 degree angle? What if we have a 73 degree angle? We can also do a similar thing here, but we're going to kick that can down the road for now. For now, we're going to deal with the special measure angles. And so, suppose the reference angle is 30 degrees, which is the same that corresponds to pi over 6. So I'll do in degrees here, and we'll do radians over here on this side. And this just needs to become part of your mental furniture. This just needs to be part of what you understand. This will become eventually, and it needs to become very soon, essentially automatic for you. Okay, so if I have a 30 degree angle in quadrant 1, quadrant 2, quadrant 3, and quadrant 4. A 30 degree angle in quadrant 1 would look like this. So what we have is, in this scenario, we have theta reference. In this case, theta reference is 30 degrees. Over here, we're going to have theta reference is equal to pi over 6. 30 degrees. If this is a 30 degree angle, remember that in quadrant 1, theta is equal to theta reference. So theta, this is a 30 degree angle. In quadrant 2, the reference angle is here. This is the angle we want. 180 back off 30, so this would be 150 degrees. In quadrant 3, remember that the reference angle always lies against the x-axis. The reference angle always lies against the x-axis. So this is the 180 plus 30 more. So theta is 210 degrees. And then I have my theta equal. And then in quadrant 4, this is 30 degrees. So this angle is what we're looking for. If this is 30 degrees, then this angle that we're looking for is 360. Subtract off the 30 we don't want. So in this case, theta is 330 degrees. 30, 150, 210, 330. Those need to become just automatic in your mind so that you can just do those at the drop of a hat. Now, very similarly is done the same way with radians. We're going to do the same thing, put each of these in each of the four, put this angle in each of the 4 quadrants as a reference angle. So in this scenario, the reference angle here is pi over 6. Well, in quadrant 1, the reference angle is the angle. So this is pi over 6. And we don't need a symbol. Remember, if there is no symbol, we're assuming it's radians. You may, if you wish, write RAD. And for some of the work we'll be doing, you want to emphasize this is radians. And so we will write RAD at times. In this case, this is pi over 6. This is the reference angle of pi over 6. But this is theta reference. The question is, how much is this? This is the angle we're looking for. Well, this is a straight angle would be pi. Think of pi as being 6/6. We need a common denominator. 6/6, take away 1/6. This is, I'm going to write it over here, so it's next to it's in its quadrant. This is theta is 5/6, or 5 pi over 6. 5/6 or 5 pi over 6. 5 pi over 6. In quadrant 3, this is quadrant 2. In quadrant 3, so this is pi over 6. So in this case, this is 6/6 plus an extra 1/6. 6/6 plus 1/6, this is theta is 7 pi over 6. And then finally in quadrant 4, this is quadrant 4. 1, 2, 3, 4. Quadrant 4, if this is 1/6 pi over 6, what we want is this angle. So if this is 1/6, a complete revolution would be 2 pi. But remember, 2 is the same thing as, we need a common denominator, 12/6. So this is 12/6, take away 1/6. Here, theta is 11 pi over 6. I always remember this because whenever I was a student, I would write this, I would cross my 11 to make it a pi incorrectly. And so this is 11 pi over 6 in quadrant 4. So if the reference angle is pi over 6, then the reference angle family for pi over 6 is pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. 6/6, take away 1, 6/6, add 1. 12/6, take away 1, and in quadrant 1, the reference angle is the angle itself. So those are the reference angle families for 30 degrees in both a 30-degree angle or pi over 6. Degrees, 30, 150, 210, 330. Those need to become registering in your mind. In radians, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Now what we'll do next is go through the same exercise, but we'll do the same thing with pi over 4 as the reference angle, and we'll do the same thing as with pi over 3 as the reference angle. That is to say, 45 degrees and then 60 degrees, respectively. So let's see if we can work our way through that in a reasonable fashion. So in this scenario, theta reference is no longer pi over 6. We're not using 30 degrees. Let's use 45 degrees, which is the same or it corresponds to pi over 6. It's not correct to say it equals, but it does correspond to pi over 6. All right. In degrees, so theta reference is 45 degrees. In radians, theta reference is pi over 4. Let's do radians first this time. In each of the 4 quadrants, and so, well, in quadrant 1, the reference angle is the angle. This is the reference angle. Theta reference is pi over 4. But in quadrant 1, the reference angle is the angle, so theta is pi over 4 in quadrant 1. In quadrant 2, this is the reference angle, theta reference. But we want this angle. Well, one way to think of this is pi, which is 4/4, take away 1/4, and certainly that would give us 3 pi over 4. But once we get all these up here, I think there's an easier way to think of this, but let's get them all present first. In quadrant 3, there's theta reference is again pi over 4. This is the angle we want. This is 4/4 plus 1/4, so theta is 5 pi over 4. And then finally, in quadrant 4, again, theta reference is pi over 4. This is the angle we want. That's 2 pi. Again, we need a common denominator of 4. So 2 pi is the same thing as 8/4. 8/4 take away 1/4, right? 8/4 take away 1/4. So this value for theta is 7 pi over 4. And to me, the simple way to remember this is these are the odd multiples of pi over 4. 1 pi over 4, 3, 5, and 7. So it's straightforward to me when I just draw this picture. This is 1/4, 3/4, 5/4, 7/4. Because it's symmetric, it works much more readily that way. 1/4, 5/4, 7/4, 11/4. They're just the odd multiples of pi over 4. And so I just mentally, if I want to know reference angle of pi over 4, and if I'm in quadrant 3, then in my mind's eye, I just go 1, 3, 5. So 5 pi over 4. If I want quadrant 4, 1, 3, 5, 7 pi over 4. You don't necessarily need to write it out. And of course, you can think it much faster than you can speak it even. But just knowing that these are the odd multiples of pi over 4 really comes in handy, and it allows you to know what's happening here. In fact, the pi over 4s, it's much easier to do it this way, I think, even than to do the degrees. Eventually what happens is you become so accustomed and you do so much work in the radians. And if any of you have any calculus in your future, the calculus essentially requires that you work in radians for some technical reasons that you'll talk about when you get there. And so everything needs to be done in radians, and eventually this just becomes, just part of your mental furniture. Let's do the same effort here now in degrees. So we're in quadrant 1, quadrant 2, quadrant 3, quadrant 4. And this, if anything, this is even more challenging because this is simply 1, 3, 5, 7. Over here, it's a little more going on. Theta reference is 45 degrees. Well, in quadrant 1, the reference angle is the angle. In quadrant 1, theta and theta reference are the same. So in quadrant 1, theta is simply 45 degrees. Remember, degrees must have the symbol. Radians does not need the symbol. If you wish, you may emphasize that these are radians. If you wish. You can use either capital R or lowercase r, it doesn't matter which. If you wish, you may emphasize it's radians, but that's not required. If there is no measure, if there is no unit given, then we assume theta is measured in radians. So if you write in this case, if you write theta is equal to 45, that is not correct. This is not 45, because this would say 45 radians. This says 45 degrees. And so if you mean degrees, you stinking better write the degree symbol when you write your workout. All right, so the next case is in quadrant 2. Going to run out of space here. Quadrant 2. So theta reference, let me make a better picture. So here we are in quadrant 2. Theta reference is 45 degrees, but we want this angle theta. That's the 180, subtract off the 45 degrees. 180 minus 45 is 135 degrees. And then now we're down here, make a better axis than that. Now we're down in quadrant 3. If theta reference is 45 degrees, we want this angle, which is the 180, add the 45 degrees. So that theta becomes 180 plus 45 is 225 degrees. And then same song, fourth stanza here. If this is theta reference always lies against the x-axis. Always lies against the x-axis. Theta reference always lies against the x-axis. Theta reference never goes against the y-axis, always the x-axis. And so there's my value for theta. Theta is, in this case, it's 360, subtract off the 45 degrees. And so theta is, if my arithmetic is correct, 315 degrees. All right? So those reference angle families need to, again, become part of just mental furniture. They're just hanging around your brain all the time, waiting to get used. Again, the reference angles for the reference angle families for pi over 4 is straightforward. It's the odd multiples of pi over 4, and it's almost hard to forget that. All right, so the last of our special reference angle families is $60 degrees. So here we're going to use 60 degrees. And 60 degrees corresponds to, what is that, pi over 3. That's 180 divided by 3. And so let's do degrees first this time. Quadrant 1, 2, 3, 4. Reference angle is 60. Do we know quadrant 1? Quadrant 1, theta reference is theta, so theta is 60 degrees. There's nothing much to do. Quadrant 2, this is theta reference. This is the angle we want here. 180, subtract off the 60, theta is 120 degrees. Now we're in quadrant 3. So there's theta reference, 60 degrees, but we want this. We want 180 plus the 60. 180 plus 60, theta is 240 degrees. Just a little arithmetic takes care of that. And then the last piece in quadrant 4, theta reference is 60 degrees. So this entire angle now is 360. Subtract the 60, that's pretty obvious. Theta is 300 degrees. 60 degrees, 120, 240, 300. Those are the reference, that's the reference angle family for 60 degrees. All right, and then finally, let's go through with pi over 3. And when we find our common denominator, it's going to be thirds. So in quadrant 1, the same story now. Theta reference is pi over 3. So theta is pi over 3. In quadrant 1, theta and theta reference are equal. In quadrant 2, here's theta reference is pi over 3. This would be pi, but back off 1/3. Right? Go the half revolution, but less than that. And so the question is, we want 3 as our common denominator. So this is 3/3, but back off, take away 1/3. 3/3 take away 1/3. Theta is 2 pi over 3. Hopefully you get to the point where you don't have to compute it every time. You simply know it. And then in quadrant 3, this is 3/3. Theta reference is pi over 3. So we want this larger angle. 3/3 plus 1/3. 3/3 plus 1/3. 3/3 and 1/3 is 4/3. So I can say 4/3 pi, but I write this as 4 pi over 3. 4/3 pi or 4 pi over 3. You may write, by the way, in all of these, you may write this as 4/3 times pi. This is permissible, that's correct, it's fine, but no one ever does it. Everyone writes it this way. So even though we may say 4/3 pi, or we may say 2/3 pi, or 2 pi over 3, or 4 pi over 3. However you say it, this is the way typically we write it. And then lastly, this is theta reference, is pi over 3. And then this angle is 2 pi. Let's subtract 1/3. Well, 2 pi is, common denominator is 3. 6/3, take away 1/3. 6/3, take away 1/3 is 5/3. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3 are the reference angle family for the reference angle pi over 3, measuring in radians. So knowing the reference angle families is very important. You need, whatever it needs, you write them down over and over again, view this video over and over again, just practice, write out a blank slate and see if you can fill them in. That's a good exercise. But you do whatever it takes so that this information on this board and the two we've done before, that needs to be just straightforward part of what you have. It needs to become just like arithmetic for you, just so automatic that you don't even need to think about doing it. This needs to be correctly ensconced in your mind so that the work we do later on, you're able to work this part of it straightforwardly.